Welcome to the TPC Desktop video series. In this video, we'll look at importing GMM files into Traverse PC. Let's start by opening up the taskbar, and in the Getting Started, let's open the Cadastral Learning Guide. I want to scroll down to the table of contents and just click on Importing GMM files. GMM files are used by the Bureau of Land Management to store Township Record information. Those of you that have used the GCDB User's Guide may be familiar with these as R files or raw files. Traverse PC simply just calls them GMM files. And we're going to end up with imported data that looks pretty much like what we've got right here. So I'm going to just slide this off to the side. And let's go ahead and open a sample survey that Traverse PC provides for this. Let's go to Sample Surveys. Let's look for Learn, Import, GMM. And I'm going to save that right away as just Import GMM. The sample files are read-only, and if we want to save our work as we progress in this, we have to give it a new file name. So let's start by taking a look at the survey information. We've set this coordinate reference system for this survey to be NAD 83 based on the continental U.S. datum. Our zone is New Mexico West, and we've picked an appropriate ellipse. So we've given Traverse PC all the information it needs to compute data per the Public Land Survey System. The other thing we'll do sometimes is go to Project Factor and set, for instance, a project elevation. And if we want, we can choose the PLSS options for the entire survey. It would be necessary in this case because our import will take care of that. So let's start our import. Let's go to the File menu, choose Import, and from the type list, we select GMM Township Record. And then we click on the three dots next to it for the settings. And we're going to tell Traverse PC that we want to add the letter R or append the letter R to the point labels. So we're going to create GCDB point labels like 700, 100R. And the R is just R notation for record. So we're going to know this is record instead of field data that we've tied. We can add any SID data to the point description. Okay, so this is source identifier information. It'll end up in the description. And we can also create a drawing of the township. So these are the settings we want. Let's choose OK. Let's browse. Traverse PC takes us back to the samples folder where we've got our raw file ready to open. So let's choose that file and choose Import. Now I want you to notice that Traverse PC tells us right up front that it used the center of the coordinate reference system as the starting position for the Traverse record. Because these are geodetic computations, the record data will compute different geodetic positions depending on where we're located in the coordinate reference system. So we're going to start at the center of the CRS, do the computations, and then anytime you want, you can translate appropriately to the correct geodetic starting position, and Traverse PC will simply recompute the township corners based on the record data. So let's choose OK and import. Traverse PC brought in 147 points, and we're finished with the file. Now we're going to see that Traverse PC isn't able to finish all the computations until it makes another pass through. So we've just got a little gap here, and that's because we're starting at sort of unknown points along the South Township line and East Township line until we finally get all the computations put together. So Traverse PC has created a drawing because we told it to. And if we come over here and open the Traverse Manager, we see that it's added a traverse for us. And it has helpfully named that for us, record, so we know it's record data. We know the township, 14 north, range, 14 west, and the New Mexico meridian. So let's open this up and see what we actually got for our data here. The first thing we notice is that Traverse PC has used GCDB point numbers for us right out of the raw file or the GMM file to label the points. And so we can see that I'm starting here at the southeast corner, basically, of this township, and I'm running my first south-north line on the east side of the township. So my bearings are pretty much true north, record distance 40 chains, until I get to the last tier where I'm going to have some overage or under chainage as I tie into that next township line. Notice also that Traverse PC has put a gap at the end of each line, and if we scroll down we'll see that each section ends with a gap. That's so that Traverse PC automatically removes any of those extraneous lines as we get to the north end of the township and then start back here the next section over and running our north line again. I also want you to notice at the top of the traverse that this traverse is set to true bearing and geodetic distance. If we open up the format, we'll see that Traverse PC automatically set this to the PLSS distance and direction types. It said go ahead and compute latitude and longitude, so we've got geodetic positions for all these points as well as coordinates. And it set up our format so that we can see latitude, longitude, convergence, and of course our bearings and distances and elevations in the traverse view. Let's close that out. Remember the warning we got that said Traverse PC was positioning the southeast corner or starting the township at the center of the coordinate reference system. We can simply come in and translate this to any position we want in the coordinate reference system, and then we can simply say I want to recompute. And Traverse PC will take all of this record data for the township and simply recompute new township corners, okay, and section corners based on that new location inside our coordinate reference system. So very easy for us to get updated positions out of all this. Of course, the record data is all going to stay the same. Now, I want us to look at a couple of things that Traverse PC has done for us. Because we're using true bearing and geodetic distance to format the data, that means we've also computed these positions per the PLSS. So at this point, we have valid corner positions based on the PLSS. We also notice that we've started in the southeast corner of the township, and we've run south to north lines. If we scroll down here, we'll see that eventually we'll start running the west line. So here's our first west line at the south side of the township. And Traverse PC is going to run all the east-west lines as it works its way north in the township. And if we scroll all the way down to the end, we'll see that the last line we run is the North Township line, starting at GCDB point 700, 700, and running back to 100, 700. Again, the R indicates these are record data for us. Now let's come over and look at our drawing real quickly here. And I'm just going to zoom in on the southeast corner of the township. And I want you to notice that Traverse PC has already set up this drawing for us, so it's labeled all the township points with the GCDB point labels. It's annotated the lines with the distance and the direction. If we come up and look at the top of the drawing, we see that Traverse PC has set the drawing to be true bearing and geodetic distance. So it's going to be consistent with our public land surveys. And then if we come all the way to the top, we can see here's that final line, 700, 700R, all the way over to 100, 700R. So we basically have got the entire township in here ready to go. If you've used Traverse PC, you know that when we go to compute lost corners within a township, either via single proportion or double proportion, we like to have a record traverse where we store the record data. That way we can simply come in and select data within the traverse. It automatically populates the dialog boxes, and we can compute those lost corners without ever really having to enter any data. And a lot of us are used to batching our data so that we can come back and recompute those positions. This makes it very easy. We basically have our record traverse for the township ready to go. And we'll come in later on and include our retrace data so we can compare the two as we compute those positions.